Okay, so this time around, let's talk about heat and internal energy. So when we talk about heat, okay, we are also, it's almost the same as that of internal energy, such that internal energy is defined as all the energy of a system that is associated with its microscopic components. Meaning to say, when we say microscopic components, it would include, the atoms and molecules. Okay. So these atoms and molecules carry with them kinetic energy, and so that is associated with also with that of heat. But heat specifically or technically is strictly defined as the transfer of energy due to temperature difference between a system and its surroundings. Okay? So where did that energy that transferred came from? It came from the object's internal energy. So the more internal energy that an object has, the more heat it could transfer. So that's how the two of them are interrelated with one another. Okay. So according to here, heat energy transfer occurs because there is a temperature difference between two systems. So temperature difference. Okay. And what's that direction of heat transfer? The direction of heat transfer is always from a hot region going to a colder region. So that is always the direction of heat flow. So that's the direction of heat flow. And so when you hear the statement, "Uy, isara ang pinto dahil lalabas ang aircon." Okay? So that statement is obviously full of wrongness. Wrongness ano? Okay, because how should that sentence be stated? Instead of saying na lumalabas ang aircon or lumalabas ang lamig, the scientifically correct expression is that pumapasok ang init, because the direction of heat transfer is always from hot region going to a cold region. Yung kwarto malamig, okay? Then yung labas ng kwarto mainit, hindi mo pwedeng palabasin yung lamig papunta dun sa mainit kasi yun nga, the direction of heat flow is from hot going to cold. So what would happen is that the warm air outside would get inside the cold room. Okay? So what are the units for heat? So the SI unit for heat is the calorie. Okay? And consequently since heat is energy, okay, the equivalent unit of the calorie is the joule. So 1 calorie spelled with a small letter C is equal to 4.19 joules. But we also have another calorie spelled with a capital C, which is equivalent to 1 kilocalorie, which is 4,190 joules. So the calorie, the one written with a capital C, this one is what we use for foods. This is the one that we would often see at the back labels of our foods. They're counted in terms of the calorie, capital C, kilocalorie. So let's differentiate between heat and temperature. Okay? So to differentiate between heat and temperature, let's compare, well, the heat and temperature of the following two objects. So we have here on this side a cup of hot coffee. On other side we have the vast wide ocean. And over here we have, this is Pearl. It's actually Pearl who is drowning. Pearl. Okay, so this Pearl is crying for help. "Help me, I'm drowning." But nobody on the sea wants to save Pearl. Okay, so going back to the lesson we have here. Naturally, if we're going to compare the two, we would say that the temperature of the hot coffee is higher than that of the temperature of the ocean, which has a low temperature as we would compare to the coffee. However, the heat contained or the internal energy of the two, well, is again not the case. The internal energy of the coffee cup or the cup of coffee is much lower as compared to the internal energy of the ocean. Because as we have defined earlier about heat and, well, internal energy is the, well, is all the energy of a system. And of course, we have there tons and tons of molecules and atoms moving in the ocean, so it contains more energy than that of our cup of coffee over here. So that's how we differentiate heat and energy. Okay? So what are the different methods that heat gets transferred from one place to another? So there are three main ways of heat transfer. As we have defined earlier, that heat is the transfer of energy. So what are the three main ways of heat transfer? So we have the way number one, which is conduction, which occurs mostly for solids that are in contact with one another. So we have two types of, well, materials according to solids. We have there the insulators, which are practically poor conductors of heat. Example is wood. And then we would have our other type, which are the conductors, well, which are very good in conducting heat. Okay, aside from conduction, we also have the other method of heat transfer, which is convection. Okay, which occurs mainly for fluids. So convection accounts for the motion of fluids due to temperature differences. For example, why do we have a land breeze and a sea breeze? Okay, it's because of convection. And last but not the least, we have over there, or we have over here, radiation, which is heat transfer that occurs through vacuum. Why does the heat of the sun reaches the earth even though you're separated by thousands of miles apart? It's because of radiation. Heat transfer via radiation. The heat from the sun can travel through the vacuum of space. That's why it could reach the earth.